our speaker.
Okay, welcome everyone. Today, Raffaella Bernardi will present his work on visual dialogue, two challenges behind visual dialogues, grounding negation and asking an informative question. Let me introduce Raffaella. Raffaella Bernardi is an associate professor at University of Trento at the Department of Information Engineering and Computer Science and Center for Mind and Brain Science. Previously, she was an assistant professor at the Faculty of Computer Science at Free University of Bolzano, where she taught computational linguistics and acted as a local coordinator of the Erasmus Mundus European Master's Program in Language and Communication Technologies. She studied at the Universities of Utrecht and Amsterdam, specializing in logic and language. She completed her PhD at the University of Utrecht by writing a dissertation on categorical type logic. She supervised PhD projects on controlled natural language to access ontology and databases and interactive question answering systems in the library domain. In 2011, she started working on distributional semantics, investigating its compositional properties and its integration with vision models. Recently, Raffaella is working on multimodal problems, especially in visually grounded dialogues. Okay. Thank you, Raffaella.
Thanks for the presentation, and thank you for inviting me to give a talk to your group here. It's indeed a great opportunity for me to start the year in this way. And so it's kind of, I will present during this talk two main work that we have been carrying out in the last year or so. And as it has been said, like they are both connected with about visual dialogues. In like a year ago or a bit more, Sandro Pezzelle and I have wrote a survey on visual question answering. So the task of answering a question which is grounded on an image. And it was like, first of all, what it appeared clear to us is that there were already many surveys because the field is amazingly productive and it went on with an important high speed. And so what we thought of doing has been to take a different view of what was already done and summarize in various surveys. And we specifically, we considered the linguistic issues that are still challenging in this research line in VQA, and in general, I would say in language and vision, for language and vision models. What we saw, we went back to Vinogard, the PhD thesis of the 70s, and where Vinogard nicely lists a number of linguistic phenomena that should be tackled at a model that wants to interact with human about a visual scene should handle. Among those linguistic phenomena, we highlighted four that we consider to be of a special importance and for which there has been some work already done, but more attention we believe should be put on that. And they are language ambiguity, so the sentence of disambiguate that has to be disambiguate when it's grounded on an image, vagueness, the fact that there are some expressions like few, most, whose meaning depends on the context in which it is used. And negation, which is highly spread in natural language and quite a lot neglected in all the statistical work that is done on language. And finally, the issue, the aspect of language, the fact that the sentence the meaning of a sentence very much depend on its use, and the way in which, for instance, we would refer to an object, it refers to the communication goal of that description, and to how we want to discriminate an object, for instance, from another one, and which is the other one. So the pragmatic aspect that are involved in language. Of those four issues, we have been working on negation, specifically on encoding a question negatively answered. Let's see what I mean with this. So it's connected with the visual question answering, with the issue of having a polar question, like, is it a scissor on the left of the picture? Yes. The meaning of this question answer pair is rather straightforward. It's referring to the scissors that are in that green box. But if the answer is negative, if the question is it the scissor on the right of the picture, and the answer is no, the meaning of this question answer pair is actually referring to what linguists call the alternative set, the set of all those objects which are not the scissor on the right. And if now this question has been asked after another one, it has already been established that we are speaking about a scissor. So is it a scissor? Yes. And then the question answer pair we had before receive a different meaning. It now refers to just a singleton, just to the object, the scissor on the left. So the meaning of this question answer pair has to be grounded both on the linguistic context and the visual one. And it's the alternative set, and in this case, it's now reduced to just being one. So what I will be presenting is our work specifically on this issue, on how far multimodal model are able to get such interpretation. Secondly, now, if we go back again to Winograd thesis, he was envisioning a dialogue. He was thinking of having the system which interact, which speak with a human. So it's also answering, it's also generating text. Now, if not only so the system has to understand, to interpret, but has also to generate text, we need to have in a nowadays model, neural network model, an encoder decoder structure. So what people have used is the structure that was a lot used for machine translation, in which there is this sentence which is encoded by the model, which produce an embedding, a representation of that, and then this embedding is used to condition the decoder, the generation of the translation. So this is the architecture that we will be using. On the decoder, what we will be inspectioning, we will consider the issue of problem solving, because answering a question is not something like describing an image, or if we are in a dialogue, we might be, it's important the sequence, the strategy, the dialogue strategy used. And this is so much true that actually dialogues and sequence of dialogues have been used in the 60s to check the children skills in problem solving tasks. So it was like what it was used was what is called the 20 question game. This is a game that was very popular in the 50s. It consists of 2 players, a questioner and an answerer. The answerer thinks of an object, and the questioner has to identify that object by asking a yes/no question. Now, which questions are asked and which is the sequence of questions asked is a strategy. It's a sign of children skill in solving the problem of identifying the object. And we will therefore, in the second part of the talk, we will I will be speaking about the work that we have done in this direction. So we take as our task they basically the 20 question game, but in its visually grounded version. This is a data set that was released by De Vries and various people in 2017. It consists of GuessWhat. So it's two agents are given an image. The questioner has to ask these these yes/no questions, and so to identify the target object that is assigned to the oracle. De Vries and they collected human dialogues. So they let humans playing the game through Amazon Mechanical Turk, and they released these important data sets for training models to being able to accomplish this task. So the architecture we have used is the one that we had proposed in the NACL paper in 2019. Is based on an encoder decoder structure, and the encoder has to encode the multimodal inputs. The linguistic input comes from the decoder, the question generator, which step by step asks questions, and then the oracle, which are answered by the oracle. And this dialogue history is then progressively given to the encoder, so that at the end of the game, the guesser try to choose the target among a number of candidates that are given to it. In the case of De Vries of humans, humans could play the game. Could ask as many questions as they wanted. Usually they ask 5 or 8 questions, but they were free to stop anytime and decide to guess. Most of the models are instead given a fixed number of questions, after which they guess the target. Now, what we showed in this NACL paper was that it's certainly not enough to compare models based on the task accuracy, on how well they do, on how many games they succeed in. Because what we show at that time, like we took the model that we had proposed and the state-of-the-art model at that time, which was based on reinforcement learning. The accuracy was rather similar, around 58, 56 for the two models, but the two models were dramatically different in the dialogues that they produce. So the GDS model that we had introduced in that paper was like produce questions that are at least like plausible questions, but the reinforcement learning model was kind of a list of repeated questions like this. Is it the top? And lots of special questions and repeated many, many times. So more than what we try to highlight the importance of evaluating the quality of the dialogues. In another paper done with Alberto Testoni, we actually showed that, interestingly, at least surprisingly for us, the number of epochs a model is trained for is an important factor in this game. Because the task accuracy is achieved pretty early after a few games, whereas models take much longer to improve the quality of the dialogues they generate. So this yellow line there is like we choose some features of the dialogues, like the variability of the words used or the number of repetition and so on. And we saw that the accuracy of the models become more human. So it's already high quite soon after a few epochs, this dot over there. And instead, the quality of the dialogue becomes more human-like as the model is kept on being trained. And this is the paper. We have done this analysis across several tasks, not just GuessWhat. And the same behavior is found. In another paper with Mauricio Mazzecos and Luciana Benotti, we investigated the effectiveness of the questions. Like with humans, what we see is that indeed the number of potential candidates reduce as the dialogue goes on. And that's what we expect to happen when a sequence of, when the questioner asks a question. So it first doesn't know what the target is, then it starts having some conjectures and reduce as it collects information. Whereas this does not happen with the dialogues generated by models. So the models do not ask informative questions. They are not effective to achieve the task. Finally, another study that we have done recently on how state-of-the-art models generate these dialogues concern the issue of hallucination. So we saw that even like universal encoders, multimodal encoders like LexMERT and VLP, they also generate dialogues containing hallucination, containing questions about objects which are not present in the image. So for instance, GDS here is asking about this image with a boy, is asking, is it a chair? But there are no chairs in the image, and that's pretty annoying. Even more like than the lack of variability in the word. And there are also some hallucination which are less severe, and that actually we found in the human dialogues as well. And these are actually more cases of based on common sense, in a way, reasoning, in the sense like in this image with the plate. Most often, like the plate is on the table, so though the table is not salient in the image, is not even that much visible, the model and the human ask questions about that, and this is considered to be an hallucination because the metric is based on the annotation of the object in the image, and not salient objects are not annotated. But crucially anyway, there is quite an important number of hallucination in these dialogues produced by the state-of-the-art models. Interestingly, what we saw is that all models hallucinate more after a question answered negatively. And this happens for all models. These are the red bar over there in the graph. And this seems to suggest to us that it's connected with how the encoder ground these negatively answered questions. And this is what now I'm going to speak about in this first part of the talk. So we checked, first of all, we wonder whether the models encode the answer at all. Then whether they understand it differently when the answer is negative or positive. And we compare these models with knowing trying to understand whether they process negatively answered questions as humans do, knowing that also for human, in a way, a negative answer is more difficult than a positive answer. And we wanted to check that. As an architecture, so we use this, the one that I showed before, but we sort of put aside, we ignore the issue of generation of the question, focusing on the guesser. So we use the dialogues that were generated by humans, the ones that De Vries had collected through Amazon Mechanical Turk. So to be sure that they were informative, the quality was correct, and so on. And what we did was to compare different encoders. So as baseline, we took LSTM and its a visual counterpart, and then Lexmet, and we compare it with Roberta, which is a universal encoder for a language, for language input only. So Roberta does not receive the image, whereas Lexmet receives both the image and the text and the dialogues. And both Lexmet and Roberta are universal encoders. They've been pre-trained on an important large number of data. And so we compared both their Scratch version, they're from scratch, the version, the same the architecture without being trained, and the pre-trained ones. So the first question we ask is whether models encode the answer to a border question. And yes, they do. So the accuracy that we obtain by removing the answers from the human, from the dialogues asked by humans drops significantly, a lot when only the questions are provided, when the answers are not provided. So there is this huge drop, and this is for all models. And this kind of guarantees that indeed the model do take the answer into consideration. We have run several experiments that we collected in this paper with Alberto Testoni and Claudio Greco, that was published last year, to scrutinize, to understand their behavior of these models. You can look into the details there, but short, brief, what we saw is that Lexmet is the best performing model on short dialogues, that Roberta is better encoding longer ones. And anyway, in general, for all models, dialogue length is a proxy of the game difficulty. So in fact, human asked more questions because it was more difficult to ask to guess the target. Okay, but what I'm going to report about today is not this issue of we're focusing on the negatively answered questions. What we observed is that quite often, many games end with a question positively answered with a yes. And this question is usually much longer than the others. And in fact, it's mostly kind of a question that summarizes the information that are already present, collected through the dialogue, as if the player already had kind of an understanding of which was the target, wanted to be sure before guessing, so kind of ask the full question with all this detail that he had in mind, almost fully describing the object. And then if the answer is positive, he decides to guess. But also an important number of games actually ends with a no. And so like in this case, is it an object? No. Is it a person? Yes. Now there are just two persons here in the image. And then the question is, does he have his right arm on the other shoulder? No. Then because it's not the one with the arm on the right shoulder, he knows that it's the other one. And the user is then ready to ask. So that question, this last question, is very informative and important to detect the target. So we divided the GuessWhat data set in two subsets, the yes set and the no set. The ones with the ending games ending with the yes answer, and the ones ending with the no. We observed that, okay, a number of games the yes set is much bigger, but what is more important, what is crucial, is that there are no reasons to consider the yes set easier than the no set, because in terms of length they are the same, they're very similar. In terms of number of candidates, they're very similar. So there are no reasons for which one would expect one set to be harder than the other. Yet, what is that all models go much worse on the no set. So the Lexmert, for instance, achieved 71, almost 72 accuracy on the yes set and just 50 on the no set. And similarly, Roberta, 69 and 54. So there is this an important drop, showing that there is like a crucial role played by this negative answer that models have difficulty grounding. For some reasons, then we saw, like, at least looking at the accuracy, Roberta seems to be a bit better than Lexmert in the no set. However, we also look into the increase of probability that the target received is assigned by the guesser after the last turn is answered. So, like, the last turn, as we said, is informative, should be in the no set, is informative, and it should bring an important boost in for the probability to be assigned to the target. And so we look into the successful games, and here we see that actually Lexmert is the model where there is a higher increase of probability assigned to the target object after the last turn. This shows that in a way Lexmert, which use differently than Roberta, Lexmert used the visual input, and this visual input seems to be important in interpreting this last turn. Still,
Raffaella,
yeah?
Can I ask you a question at this point? So,
Sure.
do these results somehow highlight that maybe in defining the attention mechanism, maybe we can separate in encoding the dialogue history, like attending to the no questions and yes questions, and then combine them, as opposed to having this agnostic way of having an attention mechanism that can uniformly attend each of these?
I think, like, indeed, the model should treat the question answered negatively differently, right? It should understand that the attention should be moved to the no thing, to the others, and I think they're not doing that. Indeed, I mean, we are sort of starting working on this issue to teach the model to that something different has to happen on now in the guesser when at the level of the probability or of the attention mechanism, when the question is answered negatively. Because as it is now, just by letting the model be trained on this without, as you say, agnostically, they are not learning to ground negation. They do use it somehow, because if you remove it, we did many experiments that we are not reporting here, but so they use it somehow, but not fully as they should, the negation. And also, like, let me add to this that what they are failing doing, okay, let me go to this other part on how the models, what we learn by comparing models' behavior with the humans. So what we did is letting human doing the very same task we asked the model to do. So they don't have to play the guess what game, they have only to guess. So they are given the dialogues generated by the Amazon mechanical turn collected by De Vries and the others, and they have to guess. So they are given the image, they are given the dialogues generated by the Amazon mechanical turn and the potential candidates, the possible candidates, and they have to choose which is the dialogue, no? Because it's a different task, the one of you yourself ask questions and then guess, to the task that we are our model to do now, which is given the dialogue, then guess. So now we ask the humans to actually do the same. We give the image, we give the dialogues with answer, the question and the answer, and they have to guess which is the target. So in this case, they have to press 1 because this dialogue, is it a boy? No. Is it a giraffe? Yes. Standing up? Then no. I only see one more right side lying down. Yes. And the dialogue is referring to this orange, to this giraffe with the orange bounding box, and that's corresponding to 1, so it has to press 1. So this is the task, the online experiment we did with subjects. We used a controlled sample of 300 games, balanced with respect to games in the yes set and the no set. We also made sure that they had a similar number of turns, 4 and 6. They were balanced with respect to the yes, no turns, and had a similar number of candidates, maximum 10. And we use prolific, which gave us the possibility of actually receiving subject using, employing subjects which were rather reliable. And we considered 4 settings when the full dialogues was given, when only the last question was given, or the dialogues without the last question. And we consider cases in which we removed all the yes questions and cases in which we removed all the no questions. And each game was presented to 3 subjects. In total, we had 48 subjects. Now, this experiment has been rather instructive for us, because it shows that models are close to human in the yes set. So human accuracy is higher, but models are close to that. Humans reach in the majority vote. So when a game was correctly guessed by at least 2 humans, the accuracy is 86, and instead with models is around 70. But what we noticed is that whereas when we consider the other setting, the setting in which only the last question is given, or the dialogue without the last question, we see that humans still perform quite well. I mean, there is a drop, but it's still a high percent of games which are correctly answered, whereas models don't go that well. So without having the last question, models just reach around the 55, 53% of accuracy. And when they receive only the last question, the accuracy is higher. So this shows that they rely a lot on this sort of confirmation question that I was commenting about before, the fact that the users ask a question at the end, which is long, as kind of collecting all the information that was received through the dialogue. And what they fail to do, and even like if now when the information is spread through the dialogue, they fail composing this information. And so that's why here is just 55%. So models fail gathering together the information that are in the spread through the different turns. And this is even more important in the case of the no question, because there, I mean, the information has to be integrated in order to succeed in the game. And in fact, what we see is that, okay, the humans reach still an important high accuracy of 80% in the majority vote, whereas these models are around 40s, 48. So the drop here is the difference is very it's huge. So models are far away from humans in the no set. And what it seems, in fact, that is playing a major role is this weakness, this the fact that they are not able to compose, to integrate the information. So for instance, here Lexmert is after all quite good in understanding in using the last turn when it's given alone. It's almost as good as humans. It's 31. I mean, yeah, it's like human. It can profit of the last question, but what it fails doing is integrating this last question together with the other information in the dialogues. So that's the failure of where the model really fail, what they really fail doing, composing the information of the various terms, which is crucial in the no set. We also observed the time that the humans spend in take in the various settings. And so what we see is that when there is a question positively answered, is faster than integrating a negatively answered question. So if we see, yeah, all cases where the last turn is positive, they are all much faster. All settings, even when we ask only the last turn or without the last or the full dialogue. And we consider only the successful games, the games in which humans manage to detect the correct target. Moreover, we see that in the yes set, guessing the target is faster when receiving the full dialogue than when receiving the dialogue without the last turn. And this is because like human indeed exploit as well. They exploit these last questions a lot. So they have the information provided there, whereas in the other case, they have to look through the dialogue to reason about building the representation of the target, whereas with the last question is provided all together there. And finally, in the case of the no set, integrating the last turn when it is a negatively answered question takes longer. So this is like when the full dialogue is given and they manage to guess by having the full dialogue at disposal. So by using, they had to integrate the answer, the information provided in the last turn with the rest of the dialogues. They take 85 seconds, whereas on average, whereas when the last turn is not given, they are faster. And this is like the games, yeah, it's faster. So what it takes time for human to do this integration, but still they succeed, whereas model, they fail. So it is indeed a hard task because even human takes time for doing that, but they succeed in doing it. And so this is like a challenge for multimodal models that I hope we are going to make progress on. Another informative last part of experiment that we did is to investigate, to analyze the errors, to see when models do mistakes that, when they are wrong, they don't correctly choose the target, they fail getting the target, they actually take as target they do the same mistake that the humans have done. And these are informative, are important because they are human-like mistakes. And therefore, there must be a reason for which humans have done that mistakes, and they are at least more plausible as mistakes than the other ones that humans have not done. And in this case, what we saw is that Roberta makes mistakes which are more human-like. So there is a majority. Around 60-50% of the games in which Roberta fails, it chooses as target the same object chosen by humans, annotator, which shows that indeed there must be some good interpretation in what Roberta does. And again, that should deserve more studies, more experiments. To conclude, what I wanted to give as a message for this part is that, okay, we saw that to some extent the answers of these polar questions are used, that models succeed in easy concatenation, but they fail to compose the information when it's spread through the turns. And in and they are really far away from humans in processing the negatively answered questions. They, as it was like we mentioned, they have to learn to put attention on the alternative set, and they are not doing that now. So now I will move to the second part. So this is like what concerned the encoder, what we understood, what we have learned about the encoder of these multimodal models. And the second part instead concerned the decoder. And in particular, what we are trying to understand is like which is the strategy, like, because as I said, we saw that humans, whereas humans ask effective questions, questions that provide information so that stepwise the structures are ruled out. Models fail doing this. The dialogues generated by models, like not that you tend to kind of ask a question which would bring into the alternative set a candidate which was already ruled out. No, and that doesn't sound smart. So we try to investigate this aspect. As we saw, like we said before, now we use this encoder decoder architecture. So there is a question, the decoder is a generator of questions which receive an answer from an oracle, from the other agent, an external oracle. And then the dialogue is given to the encoder, which embeds the image and the dialogue history. And there is this guesser, which assign probability to the various candidates. Now we do so that the guesser, so usually in the usual setting, the guesser guess at the end. Now we consider the scenario in which at each turn, the guesser assign probability to the candidates. Okay, and the question generator as a decoding phrase in which we considered it as a decoding strategy beam search, which means that at each step, the question generator provides, we consider the beam of three candidate, K3. So the question generator produce the question stepwise, but yes, these three options that it carries out, so that at the end, the ones which is most, as the highest probability attached is the one which is actually produced, uttered, and is the one that the oracle then answers. So the beam search provides a list of three possible questions. In a usual setting, the first one is generated, and we actually now instead change this, inspired by the strategy used by children. What we saw is that, so like in this paper, Ruggeri and Lombroso use the 20 questions, observe how children ask questions when they have to solve a problem. And they observe that they tend to ask questions that confirm their hypothesis. So for some reasons, they start the asking question, having a conjecturing, which is the solution to the problem. And they keep on asking questions to confirm that hypothesis till they receive a negative answer, since the hypothesis is disconfirmed, and then they switch to another one. So we try to implement this strategy. And so we developed a model that we call confirm it, which tends in fact to start from an hypothesis, which the candidate which is the highest, which receive higher probability, keeps on asking questions about that candidate till that hypothesis is disconfirmed. So specifically, now the model that we use is, as I said, like there is this external model, external oracle, which provide answer based on the actual target in the image. And to this, we add an internal oracle. To the questionnaire agent, we add an internal oracle, which means an oracle which is given the beam search questions and answer them considering as target the one to which the oracle, the guesser assign higher probability. So the one that the questionnaire conjecture to be the target. If he has an hypothesis, like in this case, he thinks that cat is the target, so he will ask the internal oracle answer the questions, assuming that that is the target. Let's see what that means. So we have this game. Is it a living? Yes. The guesser assign probability. Now this is for some reason he thinks that is this dog over here. A is the candidate with a higher probability. The question generator then, will produce through the beam search 3 possible questions. These questions then are answered by the internal oracle, considering A as the target. So is it in the middle? No, because A is not in the middle. Is it a dog? Yes, because dog, this thing is a dog. Is it a person? No, because this thing is not a person. Okay. Now, of these 3 possible question answer, of these 3 questions provided by the ranked, the beam search, then the question generator decides to ask the one which will increase the probability of the candidate that he thinks to be the target. So this one. And okay, now in this case, actually, so the target is this, but it's still it is a dog. So the external oracle answer says yes, and then the dialogue continues with this question answer pair with the answer provided by the external oracle. So now we have to ask yet another question, the follow-up question. In this case, again, the beam search provides 3 possible questions. The questionnaire keeps on thinking that the target object is this one, is A. So he answers these 3 questions, assuming that that is the target. And the ones which will increase the probability of the A of his hypothesized conjecture object is this one. So the question generator will ask this question. But in this case, when the answer from received by the external oracle is different, because the target is not A, is actually B. So he says no. And then the guesser change strategy. I mean, he understands that it's not A, and he assign higher probability to B. So this is the strategy that we have implemented in this model called Confirm It, and that has been published in the paper at MNet. So what we saw is that the accuracy of this model is higher than compared to a normal beam search strategy or a random re-ranking or greedy search. So this re-ranking strategy of Confirm somehow, like at least bring an increase in accuracy. But what we found more interesting is are this other set of results. So we gave to humans the dialogues generated by Confirm It and by Beam search and by the human dialogues, that we had from De Vries. The accuracy of humans when receiving human dialogues is much higher, is 96, whereas, but still Confirm It reach a higher accuracy than Beam search, showing that these dialogues are more effective than the ones produced by the Beam search strategy. And moreover, also the number of repetition reduced, because in a way, like also the dialogues are more coherent because they're all about the same object. Still, they answer. I mean, they are answered positively. There are less hallucination because kind of the guesser is guiding in a way, the question that are asked. And also there is somehow this strategy of asking a last question that is answered positively, and for some reason that I don't know, there are also the language, there is more variability. So there are more novel questions, so questions which were not seen during training. So to conclude this part, it seems that we have implemented this decoding strategy that is inspired by cognitive studies on how children ask questions. And it seemed like what we saw is that these dialogues generated by Confirm It are more natural, more effective, both for the model and for the human annotators. Overall, what I would like to give as a take-home message is that in general, visual dialogues are an interesting challenge to evaluate models in their grounding, in the interpretation of the grounded language, and also in this reasoning skill, because there is a lot that is behind both the generation and interpretation, and that there is a lot still to be done despite the important progress that have been achieved. And I take grounding, negation, and the development of a dialogue strategy, an efficient dialogue strategy, to be two important open challenges. Finally, to go back to Vinogard PhD thesis, in those dialogue, the model was also asked to execute instructions, not just to have an interaction. And indeed, like this issue of performing an action is what now is people are working on, like with embodied models. And indeed, I consider this to be an interesting line of research on which I hope to see more done and published, and that nicely add to the multimodal research that has been conducted in the last years. So let me thank all the collaborators, all the people I've worked on in the work that I presented in this talk. So Claudio Greco and Alberto Tessoni, who are PhD students at our university, Sandro Pezzelle and Ravi Schenker were PhD students with us in Trento and are now having their career abroad. And then part of the work that I presented was done with groups led by Barbara Planck, Rafael Fernandez, and Luciana Benoit. So thanks for the invitation, and I'm here now for questions and interesting discussion.
Thank you, Raffaella. Can I ask a question? What exactly is the target-aware external oracle?
Oh, sorry, I was not clear, but so the oracle is assigned a target, no? It's told which is the among the objects present in the image, which is the one that the other one has to guess, right? So the external oracle is the normal oracle of GuessWhat, right? The crucial difference that is a bit tricky is that we also use an internal oracle. And the internal oracle answers questions assuming that the target is the one to which the guesser assigns the highest probability. That's the crucial difference between the external oracle and the internal oracle. The external oracle is the other agent. The normal oracle of GuessWhat is assigned by the game a target, which is one of the objects in the image.
Okay. Thank you.
Whereas the internal oracle instead is not assigned. The internal oracle instead, it takes as a dynamic change, which is the target, according to the target with the highest probability according to the guess. So it's tightly connected to the guess.
Thank you.
Yeah. Thanks for the question.
So, Raffaella, maybe I can continue. So in the first part, you basically analyze the answer type as yes or no type questions. So I'm just curious about, are there any studies who also like analyze the image content in visual dialogue? Like for example, like the previous example, there are 2 humans and 2 ducks. So there might be, for example, 2 different animals of different kind. So I'm just recalling a paper by David Parikh's group called Image Specificity, that they basically analyze, given an image, can humans write somehow the same caption, or maybe the image content is too diverse that each one can come up with a different caption. Is it done in this context for visual dialogue? Because some questions, like there is definitely the category, like is it a living being? If there are many objects that are living, then of course the level of information of these type of questions will be lower.
Yeah, I understand. No, I don't think there is this careful detail analysis. Rather, I mean, because what we have done is more trying to understand some statistics about, in fact, the like when there are more objects of the same category of the target, how many games there are of this sort, whether they are more difficult, less difficult. So this is kind of an analysis that we have done, but it's more on observing the dialogues asked by the humans and observing. It was more to report statistics. We've done nothing with that kind of results, which indeed I consider to be important. Also, like there is no study about whether humans would ask, whether if you give the same game to humans, which to more than one subject, which is the diversity of questions of strategies that could be used, that could be asked, that could be used. So I continue. It has been a number of years now that I've been like working on GuessWhat, because I find it it's simple in a way, but there is a lot that it could give. There are lots of questions, research questions that could be addressed, and it will help making progress, I think. And what you are now commenting on is certainly one of those things that should be understood and could be studied.
Thank you for your answer. Okay, maybe another quick question. I think it was slide 17 where you showed the comparison between humans and these models. So there is little difference between Roberta and Elixmert. Does this mean that Elixmert or these similar language vision pre-trained models, they are not that much grounded in the image? Because like the numbers are quite similar.
Yeah, but then on the, I mean, I was also surprised to see that the blind model that like Roberta could go so well. Then what I thought was that I mean it's kind of it's not completely fair to think in this way, because first of all, because the questions have been asked by people who actually were seeing the image. So the questions were grounded in the when they were asked, right? And there is some visual part in the generation that has been used in the generation of the question. So Roberta has to now encode the questions, right? And but the questions are rather informative. And moreover, the guesser, what is crucial and what I strongly dislike is that now the guesser is actually blind. It receives the coordinates. So these models are using the coordinates a lot. They are receiving the category. And we have also like played with the idea of adding the visual. I mean, we add the visual component to the guesser. But so there is a model now. I'm not sure. Yeah, I think there is a paper now which does the right thing, which is using the bounding box, the regions of the image himself, to detect the candidates for among which the guesser has to guess. Right. And I mean, I would expect that there, if you do that, then a blind model would not be so successful as the multimodal model. As it is, the setup that is done now, it's kind of a bit unfair now in the comparison of a blind and a multimodal model.
I see.
So, yeah.
Can I ask another question?
Yeah, sure.
How is the candidate object selected at the beginning? I mean, it just looks...
Yeah, they were selected by the GUIS now in the original paper, and now there were a number of criteria, like they excluded objects that were too small. So they mostly used, I think, the size. And they add the maximum of, they also, because they use Mescoco, the image, if I'm not mistaken, and they excluded images which contain too many objects. So there are some criteria that were set up in that paper, and they are mostly based on the visual features of these the objects.
I mean, the candidate object selected by the internal oracles.
So the internal, the internal are the same, right? The internal oracles, yes, the ones, the sets of candidates are the ones that are given to the guesser. No, they are the ones given to the guesser. What happens is that at the turn 0, the guesser assigned the probability distribution to these candidates based on his bias collected during training. And so for some reasons, he assigned higher probability to the, I don't know, the cat and the dog when he's on the right, no? And okay, he's assigned higher probability. And then
so,
in
sorry for the interrupt, but can we interrupt the initial step of this candidate object selection? So we can start from different candidate objects, and at parallel we can we can generate many different dialogues.
Yeah. You could inject different priors so that you would generate different questions. That's that's a possibility. What we are now doing is starting from an equal distribution, uniform distribution, because a rational person would do that. I mean, I don't know, anything could be the target, and I would start from that. But it's also true that maybe instead, like another kind of person would be less agnostic at the start and would say, I think it's that, not because I played a lot and usually it's that, it's the dog. Or it takes the most salient. So you could have different strategies, not different starting point. You take the bigger object, for instance. And then
so, another question. So you mentioned that the text-only models are performing good in some settings. Can we generate captions for the target objects and then transfer this problem into a fully text-only problem where we have captions for target candidates, and then we try to generate questions and try to select the true candidate object by just looking at the captions of the target objects?
I think I didn't understand the question.
So I think I understood İlker's point. So what if we have a dense captioner, like instead of a single caption, it provides a more detailed description of the image. But then you apply a text-only model on this paragraph description, for example.
Yeah,
as opposed to using images.
But for doing what? Okay. Okay. So let me see if I got it right. You want to have an image captioner that describes the image. So you have a description, a densely annotated. I mean, you have a full description of the image, and to the encoder you give the description of the image, and then you ask to generate questions, right? Okay, but it's I mean fine, but it would be having a story, no, of a scene. So I think you are thinking of a question, a 20-question game that is not visually grounded, but is actually about a story, a text, which is indeed an interesting task, right?
Yeah, but I was curious about that, whether can we solve this task in this way, making it only a text-only problem, converting it to.
I understand that. I mean, maybe it's a way to go. For me, it would not be that satisfactory in the sense that you kind of have a shortcut. No, you are not. I mean, I'm trying to work on this because I would like to have this multimodal model. Not the fact that they do this integration, and then I would not be happy with having found a shortcut.
Thank you. Can I ask a last question? So we are trying to select the question maximizes the current candidate's probability, right? So could someone design a system that generates questions by minimizing the candidate object selection uncertainty? So, I mean, if there are 3 living objects and 3 non-living objects, at the beginning, a human wants to divide his or her options to 2 parts. And then, for instance, if we are asking questions about living things, for instance, there are humans and dogs mostly. For instance, a human is going to ask a question, is the human? So if it's not human, then candidates are, the number of candidates are decrease, right? Could we design a system that minimizes that the candidate object selection probabilities entropy.
I agree that this is an interesting, I mean, it's connected with this challenge that I try to kind of push forward now, of developing decoding strategy that are taking this issue into consideration. And as far as I know, there is not much work done in this direction. So there was some work 2 years ago from Santa Barbara trying to work on information gain. But it was just kind of a first work, and I think more should be done on that indeed.
Okay, thank you.
Thanks for your set of questions.
Okay, I think we can thank our speaker. Thank you, Raffaella. And yeah, this is, I think, one of the most challenging problems in this integrated vision language domain. And yeah.
But it's fun. And
yeah, of course.
Yeah. So I hope to see more done in this direction. I will stop sharing so that I can see you all better. Okay, so thank you very much for this invitation, for this opportunity. It's certainly a good way to start the year.
Yeah,
and let's hope
to see you in person soon. Yeah.
Yeah. So thank you all. Bye.
Bye.
Ciao. Ciao.
Thank you, Raffaella.
Thanks, Ilke. Bye to all.
Bye.
Bye.